In this Abaqus tutorial, I'm going to show you 5 small changes that can make your simulation faster, more reliable, and more accurate. If you're running into errors, slow jobs, or weird results, this might be exactly what you're missing. So let's get started. Setting number 1 is to set your working directory. There's nothing worse than finishing a simulation and wasting time trying to find where Abaqus saved your results. Or in the worst case scenario, your temp file is a mess. Let me show you how to fix it. You need to open Abaqus, then from File, go to the Set Work directory. And by default is in C/temp. Then you need to select this one, create a new folder, put the name of example, for instance, and select on example and click on OK. And as you see, the new work directory is C, temp, and example. And if you click on OK, a new work directory would be set. And from now on, every change you make or every file you create would be saved in the example. Now, if you go to the job, for instance, and you create a job and continue, click on OK, and then write an input file, then click on OK. As you see here, you have the job one saved. And if you open the directory here in the example, you see the job one is saved here. It's the same as the ODB file or error file, message file, or everything else. Setting number 2 is the viewport control. If you're writing your thesis or an article, your results must be professional. You cannot just eyeball the rotation when you're taking a screenshot every time. So by setting up and saving your viewport angles, you ensure that every single image lines up perfectly. Here is how to activate that. So in Abaqus, you need to go to the view, and from toolbars, you need to select views. And after that, you would see that there are different views here. So you apply front view or back view or any different views here. Then you can also set your own angle. So if you have different welding parameters and you want to snap them perfectly, you need to select the rotation, for instance, something like this. Then after that, you need to save the view, and you can save it on user 1 and click on OK. And every time you want to change it, you can select 1 and it is on view number 1. You can save up to 4 like this, 1, 2, 3, 4, or you can modify the defaults. Before we move to the next one, I want to ask you a favor. If you enjoyed this video so far, please leave a comment for me down below. It's totally free for you, but it helps me a lot to grow. If you want to support the channel, you can click on these 3 dots and click on thanks, or you can click on the link here to buy me a coffee, or you can join the channel. Thank you very much. Setting number 3 is to preset your output requests. By default, Abaqus wants to save every piece of data at every increment. In this case, you are ended up with a massive file that eats up your drive. And there's one way to set it up actually before you run your simulation. In Abaqus, you need to go to the step, and here there's one field output or create history output. If you click on create history output and continue, you can select the interval, for instance, at every 5 increments. And here you can also select on set, and you can select RP point. Then you can select the RF2, for instance, and from displacement you can select U2. And if you click OK, you would see there's a history output here. And if you create a job and run it and going to the results, you would have the contour here. Then if you want to create XY data, you don't need to go to the ODB field output and selecting the unique nodal or U2 RF2, then selecting the reference point, stuff like that. Instead, you can go to the ODB history output and click continue, and you have this one, RF2 and U2. You can select these two, then you can plot them. In this case, you reduce the file size and you make your life easier because you can directly plot your graphs instead of selecting them every time. If it is only one file, it's okay, but in the simulations with multiple runs, it can be frustrating. Number 4 is an absolute lifesaver. Increase your solver attempt. If you leave it on the default, a perfectly built model can fail and throw you the too many attempt error. And why? Because the math got tricky for a second. But don't worry, I show you how. Simply go to the step, and from other, you can go to General Solution Control and click on Manager. And here click on Edit and Continue. Here you need to click on Specify. Then in the time incrementation, click on More here. And by default, this attempt is on 5. But you can choose another number like 10 or a high number like 30 and click on OK. And in this case, you make sure that you don't run to the annoying message, too many attempts. Now let's test it on another model. Here I have only 5 attempts for this. I want to submit a job. Let's go and monitor this. And as you see, we have too many attempts made for this increment. Now let's go and fix it. In this step, we have to go to Others, General Solution Manager, and here More. Let's put it on 10. Then you submit the job here. Okay, yes. And let's monitor the job here. And as you see, it ran perfectly. Last but not least, number 5, unlike your CPUs. By default, Abaqus only uses one processor to solve your model. If you are sitting and waiting for the job to be completed, your laptop or your PC only use a fraction of its power. But you can change it in Abaqus before you run your job. You need to use the parallelization. So in the job, when you create a job here, continue, you have parallelization, and by default, it is on 2. You can use multiple processors. We go one with and one without that. So first of all, this one, and then we can submit the job and click on OK. Then we create another job. And in this one, job 3, we continue, and here we can select, for instance, 8, and in the memory you can select 100, then click on OK, and then you submit the job and we wait. Unfortunately, this option is not available in Abaqus Learning Edition. So the first one is completed. Now this is the second one. Let's see how long it took. We go to the monitor. And the first one is started at 22:15 and ended in 22:15 and 55. And the other one, if we monitor this, you see 22:15 51 and 22:15 17. So it's much faster, but this is a simple model. If you try it on a very huge model, it makes a difference. And that's it. I hope you enjoyed this video. If it was helpful for you, smash the like button and don't forget to check the video on screen before it ends, and I see you there. Stay tuned.